Hello, thank you for coming and welcome to this special Data Mesh Summit. I'm very excited to be here. I'll be your host for the day. I'm Brandon Byers, the head of technology for Thoughtworks North America. We have a pretty distinguished group of folks who will present today, some representing their organization's journey down the data mesh route, and a few select tool vendors as well. And I think both perspectives will enrichen the conversation. Like microservices, data mesh is tool agnostic, and we are certainly not here to advocate for any tool over another. But what we found in the microservices journey over time is that the industry had to learn certain patterns, and the tooling had to support those patterns around container orchestration, observability, what have you, to make implementing microservices feasible at scale for most organizations. For the early days, it took quite a bit of willpower and talent to implement microservices. It's much easier to do so now at scale. And we anticipate data mesh taking a similar journey over time. We want to make sure that we have an environment today where both the presenters on stage and the audience feel comfortable where we are in the journey. That we're going to hear lessons learned, and some of those lessons may include the mistakes, because that's taking some wrong turns, and course correcting is how we find which patterns work and which don't. And given where we are, data mesh is 3 years old. We're still quite early on. So we're really hoping to hear a diverse set of experiences and allow us to have conversations around which patterns work and which don't. Today, we're going to open with the one and only Zhamak Dehghani, my colleague at Thoughtworks. We are both part of the Doppler group at Thoughtworks, which is the group that puts together the technology radar. A privilege to work with that group and with Zhamak in particular. She is the brains and inspiration behind data mesh 3 years ago. I recall some of the early drafts that led to the article that she released on martinfowler.com and the client perspectives around how to make it work before there was a real established set of principles that she helped create around that. She's going to talk about her journey through data mesh, where we are today, 3 years in. What does the state of data mesh look like as she sees it? And she's obviously pretty well networked into the organizations who are working that journey, both with Thoughtworks and outside our own organization. And I'm particularly excited on the timing, because we're going to hear from Zhamak through the presentation today, and we will hear again shortly from Zhamak through the printed word. Her book is about to be released, and so we have an opportunity to get a snapshot today and then a much fuller picture in the book that's coming up imminently. So without further ado, welcome Zhamak.
Hi everyone. To get things started at the conference, I thought I'd share a little bit of background on data mesh, where we have come from and where we are today. Well, 3 is a magic number. According to the ancient Greek philosophers and the mystics, and the songwriter and the singer Bob Darrow. And in fact, it's been 3 magical years since 2019, when I first gave this talk at O'Reilly conference, and I shared some of the observations we had globally across our clients with the challenges of the existing data architecture. And as you can see, at the time, I didn't have a name for the solution that we were proposing. In fact, I still hadn't cracked the hardest problem of technology, naming things. But what I learned in that conference from the audience was that the problems we're seeing with our clients were more common, and they were shared by many of the people in the audience. We had data scientists and data users in the audience that they were nodding their head when I was sharing that despite many data solutions and architectures and investments, we're seeing challenges with accessing trustworthy, usable data for ML training and analytics. And in fact, when data scientists or data analysts find the data that they want, they have trouble trusting it, knowing where the source is and what processes it has gone through. And when they get to trust the data, they have trouble making meaning out of it. So they spend a lot of their time restructuring and reconfiguring and repurposing it for their analytical use case, whether it's writing reports or training machine learning models and defining features for that. The data engineers and data providers in that audience were also kind of nodding their head when I was describing this division that we see with data teams and all of the other digital kind of people in the organizations, app teams and so on. The data providers themselves, the data engineers, were struggling to get their hands on reliable sources of data from application team, from the system of records, from the SaaS products that had no intention or no incentive really to share trustworthy, reliable data that can be used for analytical use cases. And they were kind of stuck in the middle between the users and the actual sources of the data. And the leaders in that audience were also acknowledging the fact that despite the investments and yet, the next generation data tooling, they were not seeing the results that they were expecting from their investments. So I left the conference feeling confident that there is something here, there is something to challenge and, scratch the surface further. And a few months down the track, I wrote this article that really incepted this concept that by now I had a name for it, distributed data mesh. The article introduced some of the underlying assumptions that I thought we should be challenging. I mean, the technology has gone through a lot of innovation. We have many different solutions. We have solved some of the hardest problems around data volume and data velocity and data storage and processing. But yet it seemed like there were some assumptions that we hadn't changed. And the most important one that Data Mesh challenged in that paper was this monolithic nature of the architecture and technology solutions that we were building. What this diagram shows is despite the fact that we get data from so many different sources, every touch point in the organization is generating something that is valuable for us to assess and gather insights from. And despite the fact that data can be used in so many different use cases across every single business unit, across every single of those touch points, we yet assumed that the technology sitting in the middle should be somewhat monolithic and should centralize the data so that we can correlate data, so that we can make meaning out of it. Whether it's a lake or warehouse, they're all have this kind of monolithic nature. And as a result, the people who are responsible to take care of that technology and have the accountability around the data are also siloed and put in a centralized data team. And they're siloed because they're just data specialists. They know how to use the data technologies. And they're stuck in the middle, right? Behind these walls, between where the data actually comes from, the people, away from the people that know that data most intimately, because their data is a byproduct of running those applications they write and they maintain. And a wall between them and people who know most intimately how to use that data and where to use it. So they become a bottleneck. And when we think about how technology solutions are created, they're also technically partitioned, right? They're optimized for moving data, for ingesting data. They're optimized for storing large amounts of data. They're optimized for processing a large amount of data. So these are technical concerns that absolutely we need to have solutions for and optimize in terms of data movement and data processing, time and so on. But they're not optimized for how people work. They're not optimized how organizations scale, how teams get formed in organizations in a way that is in step with organizational scale and growth. So the paper challenged these assumptions and then introduced an alternative approach that builds upon the technologies that we have had and the problems we had solved, but it addresses a new set of problems we we have to solve. It addresses getting value from data at scale in complex organizations in an environment that's constantly changing. And it looks at both the organizational aspect, the roles, responsibilities, how do we divide work, how do we integrate work, how do we communicate, and also the architecture. How do we decompose what constitutes analytical data? How do we decompose and recompose that with, with code and policies? Data mesh, in its simplest form, is founded on these 4 principles. And the reason we started sharing the principles and not specific practices and technologies, and that was very intentional, because technologies and practices mature and change, and hopefully, they improve over time. But these principles are here to stay. So the very first, excuse me, foundational principle is this idea of domain ownership. Is that modern digital businesses, the way they scale and the way they have restructured themselves is that they create these business-oriented technology teams, right? You have a set of people who are responsible for building, running, operating applications that support a particular business. So you have your e-commerce team, or you have your planning team, or you have your logistics and routing, or you have your retail team, right? You have these teams within the business, and they are taking care of your applications. They're enabling and empowering your business with technology. What data mesh does is says, okay, we're extending the capabilities and also accountability of those teams to serve and share data for analytical purposes, and also embed ML and analytics in the domains. So we're removing any middleman, any data team middleman for moving data around. We're going to be able to peer-to-peer consume data for analytical and ML use cases, which are very unique in nature, right? They're very unique and different from transactional data. By having this long-standing tech, business-aligned tech and data teams. So that's domain ownership. But as you can imagine, some other problems might arise when you do that, because you can create this data siloing, right? I'm order management, so I have all the data and need to optimize processing my orders. And I have no incentive to share that data with anybody else because I don't care about their needs, really. So the second principle is data as a product. And what this principle tries to address is the data siloing. So on the surface, it basically shifts our relationship with data. That data is not an asset that we collect, but it's a product that we share, and we are accountable for the experience of those data users, or the data scientists and the analyst. And it seems rather intuitive, right? If we want to be data-driven and have all these big data bets and missions on our walls, we really need to bring accountability everywhere in all of our teams to share that data as a product. But when you scratch that rather simple or intuitive principle underneath it for teams to be able to share data as a product, the data that is understandable, that is trustworthy, that is respecting privacy, and it is domain oriented, and it is independently changed, continuously changed from other data products, we arrive at a very specific kind of architecture and set of technical practices that we get to discuss. The third principle, self-serve data infrastructure, is to address the cost problem, the feasibility problem that arises from this decentralized ownership of data products, right? The costs start going up the moment we spread that responsibility across, and the feasibility of having the right people to be able to do data work, the data product developers, owners, it becomes lower. Like it's going to be hard to resource people. So what this principle articulates is a new way to look at infrastructure with higher level of abstraction of complexity of data infrastructure that we have today, so we can lower the cognitive loads of these teams so that generalists app developers, programmers, people, majority of the kind of resources we have, people we have in our organizations are able to do data work, are able to create those analytics, are able to create insights, are able to create and share data products. And final principle is around doing all of that without compromising security, privacy, making sure that data is discoverable, making sure when we are connecting data from 3 different domains, where we are connecting customer information across our e-commerce and retail shops and the order management, we can still make sense of who the customer is. So data mesh introduces both an operating model, how we make governance and accountability and a federated accountability by every single domain, to have a stake at that, to have a stake at complying with these cross-functional policies that apply to all of the data products and all of the domains. And also it introduces a technical approach in creating, evaluating, and imposing policies at every single data product computationally in an automated fashion. And this is not something new. We have had policy as code well understood and well established in the APIs and microservices in the operational world. We have technologies that are converging on standards of articulating policy as code and maintaining policy as code. We have to bring that to this concept of data products and data mesh. So what does it look like visually? You will have your domain teams as you do today. If you are a modern digital business, this should be fairly familiar. This blue and green ellipsis representative of your technology and business teams collaborating around a particular business outcome. Here might be your product catalog, like the products of your company and creating the products or visually capturing what they are and capturing their information. Product management, so the other domain might be your logistics and routing to move products from, to your warehouses, to your shops, to retail stores. And there are applications that these teams are maintaining to achieve the function of those business units. In addition to that, those teams are now augmented with people whose responsibility is providing the data that those applications generate for analytical use cases to a new set of users, to delight a new set of customers, the data analysts and data scientists in their domains or in other domains. And to do that, we define a new architectural quantum, a new unit of architecture. We call it data product, which encapsulates everything that is needed structurally for this thing to share analytical data or insights independently, right? So data change independently, data schema changes independently, and it provides a particular set of data, like products that have been created and changed over the long period of time. Usually analytical assessments are temporal, and provide that in a trustworthy fashion and a reliable fashion to the rest of the organization. Data mesh introduces kind of the 3 classes of services that your platform needs to provide in a self-serve manner. The infrastructure that you probably have today, your storage, your compute, your warehouse, your lakehouse, or any other kind of data utilities that you have or data infrastructure. But then it introduces a new classes of services to really give a seamless experience of a data product, discover data product, manage its life cycle, observe its metrics and performance, and then computational policy as code that the platform enables embedding that in every product. So when a data product code is writing data or reading data, or somebody's accessing for that data, right then and there, the access control policy can be evaluated. Right then and there, differential privacy can be implemented. When the products get externalized as a data product, that ID of the product gets harmonized with the global ID that identifies that product in other domains. So if you are interested to know a little bit more about the details of each of these principles and where we are, please have a look at our websites. We have recorded a bunch of webinar series around each of these principles, and hopefully you find them helpful. So that's where we've come from over the last 3 years, but let's see where we are today. Definitely there is a growing industry interest that we see, and that's why you're here, I suppose, and that's why we have this conference. And if Google Trends is any indication of the curiosity that we see around data mesh, that's definitely rising. From the very early days that data mesh even didn't exist as this concept. I know that data mesh name apparently has been used on a private article before, but it was a zero search on in February 2019, and now the interest is rated as 100. And the interest, the way Google Trends assesses interest, is the portion of the search for this particular term compared to all of the other search terms that they have. In terms of countries, I think it's definitely a global, almost a global phenomenon, not quite, but with China leading in terms of interest, it wasn't the case. China definitely wasn't the first, but it's leading. But the Northern Europeans, I think, from very early on, for reasons that I have some hypothesis for, but countries in Norway, Sweden, Netherlands, and Northern Europe particularly has been interested in this topic. And the related queries are, people seem to be interested with data mesh versus lake, fabric, data mesh architecture, and of course, Martin Fowler, because he hosted data mesh blogs early on, and I'm very grateful for that. So, a little fun fact, data fabric, which has been a well-established term since a long time ago, 2010 onwards, it seems to have had a steady kind of search. People have been interested in the term, but just as of this month, it looks like data mesh has exceeded interest in data fabric. So, with every new concept, particularly the concepts that challenge some of our age-old assumptions, comes confusion, misconceptions, and a bit of drama. So I want to share some of these fun facts with you. The big one around the confusion that I see people ask, and I've seen a lot of articles published online, is this: what's the difference between data fabric and data mesh, and how do they relate to each other? So I thought maybe I can share my perspective. As far as I know, kind of data fabric, circa 2014 and even before that, was introduced as a system layer, storage layer solution to allow accessing data on disk in hybrid environments. So it was really a system of data integration and access to data, particularly with migration to cloud. And I have heard of this, what's known as data fabric story, where NetApp CEO or CTO, I'm sorry, I now don't recall the exact title, talked about using their systems and products as a way of, as your strategy to cloud, right? So you can have your data some on the cloud and some on the different data centers, and yet be able to access them. So that's its origin. So its origin is really where the data lives. Data mesh actually doesn't care where your data. Data mesh does not care about your physical hardware and software and virtualization and all of those things. You can use them or you cannot. You can just not use them. That's up to you. Data mesh is really a logical layer concern, and it's not something, unlike data fabric, that you can go buy a solution. It's not something you buy, because it focuses on accountability and responsibility of people and organization to share data that is free of bias, to share data that is trustworthy. So it really relies on kind of the data responsibility, data ownership responsibility, but then it decouples and decentralizes that around the access of the business, so it can scale out. So it can scale out. It's really a socio-technical approach. Of course, data fabric definition also has morphed over time, and circa 2017, analysts and at Gartner seem to have extended that data integration origin to now perhaps throwing kind of metadata, whatever that metadata is, some information about your data And adding some other technologies like knowledge graphs, other technologies that helps you make meaning, I guess, get meaning from your data, to run analytics on the data that's been integrated through this physical fabric. And I think while there might be some overlap between the two, the main difference that I see, again, is that the roles and responsibilities of people is absent in that conversation. We still try to throw technology at a problem. This time is ML and automation and metadata, and still, and try to solve the data accessibility, data trust, data ownership problems. I mean, we can throw a lot of stuff at data that comes in as garbage, and still we get garbage out. So I think that's the perhaps main difference. But I'm sure there is overlap, and at a physical level, data mesh doesn't even concern itself. Also, there are a bunch of misconceptions. I mean, partly because this is still, despite our best effort to share experiences and learnings, there's still, I think we're at the early days, and there are some kind of obvious misconceptions. I picked my some things on top of my head to share with you. The very first one is this confusion that comes from people who have been in data space or data modeling and data warehousing for many years. And they're very much, their kind of view of the world is more around how we model data, and especially like how data warehousing we model data. And when data mesh talks about domain-oriented data ownership or domain-oriented data modeling, there seems to be a confusion between the subject-oriented data modeling that we have done in data warehousing. And why there is an overlap between the two, like, you in your warehouse, you can model your customers or model your products or model your retail shops or model your partners as subjects. The main difference between the two is that you can do subject-oriented modeling, go into a room and do it by yourself, and then you can evaluate that, you can run a lot of different fun queries on it, but it doesn't necessarily reflect how your business is structured and generates data and change data independently. So in case of domain-oriented data, is that we look at data mesh, we look at the business, we look at the business units, we look at the teams that we have, we look at the systems we have, we look at the data that they're generating. I'm sorry, I should have put my phone on pause. So I'm just gonna stop it here. Where the data that we are generating, and then we kind of structure the data and the data ownership around this business domain. So it's not something that we design; it's something that we discover and already exists in the business. The other one is that when your data team is doing data mesh, which is great. A lot of the data mesh initiatives obviously starts with the chief data officers, chief data analytics officers. But if we can constrain the scope of that work to just the data team, it's just going to be a very expensive engineering effort that is not going to ultimately achieve its purpose of a scale with growth, because you really want to take the accountability to the domains, and you want to remove this data team as a bottleneck in the middle, right? Data product also has been a point of confusion. Is data product is nicely bundled, cleansed data with some metadata around it? Well, it's that plus more than that, actually. Data product is active, it's no longer passive, as in it has the code that maintains and generates the data. It has the code that shares that data in multiple modes. It has the SLOs that guarantee the timeliness and quality of the data. It has APIs to discover documentations and semantic and syntax of the data. And it has APIs to configure a policy. So it's policy, code, data all together in an autonomous unit deployed and shared around the domain, around domain concepts, right? Some people think data mesh is just this wavy, hand-wavy thing that is all about teams and domains. Yes, it's data mesh has a lot of empathy for people and organizations, but it's also technology. And some people think you can just buy technology and get data mesh, and that's not it either. And also a new trend that I'm seeing is this, that we have a streaming data mesh or a non-streaming data mesh or event-driven data mesh and non-event-driven. In fact, data mesh is multimodal. The whole purpose is that we put the native experience of the data users first, and then syntactically, how do we structure that data? So data users, some of them like events, and some of them actually like Parquet files, and the other ones like tables. So data mesh is by definition multimodal. So that's a little bit of a paradox, that last point. And of course, for drama, where do you go? You can go to Twitter and sometimes to LinkedIn. So these were, again, some of the highlights. Some come with popcorns to just watch data mesh drama, and some have the badge of honor of fighting the data mesh, and some are just generally funny. This one was a funny one. A data mesh is just a net you use to catch data fish in your data lake out of the data boat you keep at your data lake house. That is genuinely funny. I actually try to stay from all of the water analogies to get out of this whole lake boat scenario. And there are some grumpy ones from people that have been in the industry for a long time. They've jaded, they've seen it all, and this is yet another attempt in decentralization of data. And well, we should keep trying, because what we have had perhaps moved us a little bit forward. Perhaps the fabric has been helpful, data virtualization has been helpful, but it's been helpful at a kind of a physical layer, and we still haven't cracked the problem of decentralized access to data in a responsible way. So I will keep trying. All right, where are we with our communities? So we have definitely a growing interest in sharing and learning and and communities of data mesh. I have to give a personal shout out to Scott Herleman for creating this community. We have Slack, meetups, podcast as of recently, and he's been the man behind putting this together with the purpose of really learning. We connected about a year ago after I had received a bunch of inbounds in terms of like, can we have a Slack group? And I thought learning was a good theme to put a group together. The members have grown very quickly. We have over 5,000 people in almost a year now. And just to give you a comparison, MLOps community, which is also a very vibrant and wonderful community, and has been around for 4 years, has about 8,000 members. So Go Data Mesh Learning community. In terms of adopters, I personally know of about 200, I would call them lead adopters, for those courageous companies that are comfortable with emerging technologies, that are somewhere on that journey of adopting data mesh, and from many of whom we will hear today, and I'm excited to see where they are on their journey, what they're going to share with us. The clients are, the companies are worldwide. They're both public sector, private. Industries are just across the board, from finance, healthcare, entertainment, airlines, retail, federal services. But if I kind of step back and squint my eyes, I think the common thread across all, despite that they're all different shapes and sizes and colors, is that they all have big bets on data and AI. Some of them you will hear from Intuit, for example, today. They see themselves as an AI-empowered platform to give this wide variety of financial services to their customers, and through knowledge of their customers, give them the best experience and the best products through their platform. So I think they all have big bets in terms of their strategy, relying on data and analytics. And in terms of technology providers, they have certainly leaned in, and that is really exciting. And you will hear from some of the leaders who are repurposing their technology toward data mesh deployments today. And I'm excited to hear how they are repurposing their technology today and what their strategy looks like in the coming years. But there is still a high cost of integration. I mean, at heart of data mesh, there's this concept. It's like, you can think of it as the microservices, I guess, data in a way that tries to bring data transformation policy together as an autonomous unit with clear APIs and contracts, so we can manage change, right? We can abstract complexity, which is very different from kind of pipeline model that we've had in the past, right? And to really adapt the existing technologies that really sit at this kind of infrastructure plane to come together and be reintegrated in this decentralized model around data products, there's still a fair bit of work to be done. So just imagine that multimodal output port. Every data product shares its data through this concept of what we call output ports of your data product in multiple modes. So if you have a data analyst that wants to SQL query the data, the same data semantically, it's your orders data, they come to a different output port versus if a data intensive application wants to look at the events, they come to a different output port, and it's the same data products because they're domain oriented, not technically divided. And in case of your data scientists, maybe they come and read data frames and look at Parquet files. So if you want to bring three pieces of different technologies to give you just one access to output port, that one piece requires technologies that haven't played very nicely together in the past. So there's a high cost of integration. And also, if you recall those two other planes in terms of giving a native and kind of natural experience of just managing the lifecycle of data products as one unit, or managing the mesh of data products as another unit, still a high cost of integration because technologies like the data catalogs that exist, or observability tools, even though they're helpful and they're useful and we can kind of integrate them into a mesh or repurpose them for a mesh configuration, they're still built based on an assumption that data is kind of this passive, untrustworthy files or tables you had on a disk, and you kind of have to build all of these kind of trust metadata in the data catalog outside of the data. And this model is absolutely reverse, right? But they absolutely can be used, but it's just you have to pay attention to how well they integrate. And I hope that in the next few years, really, that this integration cost comes down. So I think we've got to answer deeper questions. The last few years, we have got our head around what is this data mesh thing and whether we should care about it. And I think in the coming years, we've got to get to talk about how do we design the architecture, establish a new language for the architecture, and how to get started with organizational change, with execution and strategy. These are the topics that I definitely cover in my upcoming book will be available mid-March. And hopefully the book can create a new language and a new framework for discussion. What comes next? Well, if we gather together next year, what should we talk about? If you're interested in the questions we need to answer in the coming years, join me for the closing keynote at the end of the conference. I see you all there.